All right, this is our last set of notes. This is 15.4, compound probability. So let's define what actually are compound events. Okay, so let's write that definition down. Okay, it's going to be an event in which there is more than one possible outcome. Okay, so an example would be just a general, like flipping a heads on a coin toss and getting a 3 when you roll a fair number cube, okay, or a die. So out of these compound events, there's two types that we're going to talk about first. Okay, and feel free to pause this video if you need to. We're going to talk about an independent and a dependent event. Okay, and that's associated to one formula. And then also the main thing about this one, okay, this independent and dependent event, there is more than one sampling right here. So I'm highlighting this, okay? So I would circle that with your pencil or get a highlighter, okay? So there's more than one sampling, okay? And you'll see what I mean when I explain this, okay? So let's write down what an independent event is. This is going to be a type of an event if the occurrence of the event does not, okay, so I think that's important, does not affect how another event occurs, okay? So this is when something does not affect how another event occurs. So let's look at this example here, okay? And we'll write out using the formula. So let's actually write down the formula first. So here's the formula. You're going to take the probability of the first event right here, and then you're going to multiply it. So this is the key thing right here, multiply by the second event, okay? We're going to multiply. So in this case right here, we have, it says to choose a green apple for a bowl of fruit, then replace the apple, then choose an orange from the bowl, and it says the bowl contains 3 apples, 2 bananas, and 5 oranges, okay? So if you just quickly randomly grab something really quick, okay, and you don't like sit there and search for, you know, the shape of it, but if you simply grab, we want a green apple first. So how many apples are there? There's 3 out of how many total? 3, 2, and 5. That makes 10. So there's 3 apples, okay? Now this formula calls for multiplying because this is more than one. See, so more than one sampling, meaning I'm choosing this apple and then I'm going to choose something else. So that's why there's 2 samples, okay? So then what did I want to choose on the second one? I wanted to choose an orange, okay? So how many oranges are there? There's 5 out of 10. Okay, and you'll notice the way I choose the apple, I put it back in the bag, so there's still a total of 10. That's why this outcome over here does not affect the first one, okay? So we're gonna multiply that out. That's 15 out of 100, which is about 15% chance we have of doing that, okay? All right, so let's look at what the dependent one looks like. It's probably gonna be the opposite of does not, so let's see. So this one is going to use the same formula. This is going to happen if the occurrence of the event does affect, okay? So it does affect. I'm going to highlight that because I was getting mixed up with that last time. So it does affect how the other event occurs, okay? But notice we're still going to use that same formula. So let's take a look at this example on how that is taking place. So it says the probability of choosing a heart and then another heart from a standard deck of cards. So if you're playing cards and the dealer tosses you a heart, or not, I'm sorry, tosses you a card, and then you look at it, and then he tosses you another card. What are the odds that those are both hearts, okay? So you gotta be familiar with the deck of cards. So how many hearts are there? There's 13 hearts out of a total deck of 52 because it's a standard deck of cards. We're not gonna include jokers. So I got the first heart supposedly. Well, if I got the first heart, that means there's only 12 cards left out of a total of 51 because it's like a card game, you know, you're keeping your cards. It does, and plus it doesn't say that you replaced it, okay? It'll specifically say you replace the card back into the deck, and it doesn't say that. It just says you choose a heart and then another heart. And so that's why you see a 12 out of 51. Okay, so let me get my calculator because I don't know those numbers. So 12 times 13 is 156 out of 52 times 51 is a big number, so 226, 52, okay? Does 156 go into that? Yes, it does. It goes into it 70 times. So you have a 1 in 17 chance of getting a heart and then a heart right after that, okay? So just to kind of see what that looks like in percent wise, it's about a 5.9%. So almost 6% chance you have of getting a heart and then another heart right after that. All right, so those are your first two types, and those both deal, again, with more than one sampling, okay? So when we go to these next two types, you'll notice it says it's only one sampling, okay? So one thing that we are trying to find the probability of, okay? So this one has a formula. Let's go ahead and reveal that. So this formula is an adding one, okay? So we're going to take the probability of A and add it with the probability of B. And then we're going to minus the probability of A and B, which this is an overlapping, okay? So let's look at the first one. The first one we call mutually exclusive events. So let's write the definition of that. This is in which events that cannot happen at the same time, meaning there is no overlap, okay? So basically, this formula is not going to include that last part. So this one, because the overlap is simply a 0, okay? So that's a 0. It does not exist. So if that's a 0, then really you're looking at just the probability of A plus the probability of B. Now you can still fill it in because you're minusing 0, okay? So you're just doing that part only, okay? Because it does not exist. There's nothing there. So here's a little Venn diagram to kind of show how there's nothing in common here. There's no overlap. Here's A over here and here's B over here. So, and let's look at this example. There's actually two of them. You spin a 4 or a 6 in one spin, okay? A 4 is completely different from a 6, so it's not going to be any type of overlap, okay? Let's look at the second one and actually write out the equation. Rolling a 4 or an 8, okay? The other thing, keyword is this or. You see how it says or? That means it's one sample, okay? So what's the probability we roll a 4 or an 8 on a 10-sided die? So this one's a unique die. So there's only one 4 out of 10. And then remember, we're going to add. There's only one 8 on the 10-sided die. So we have a 2 out of 10 chance, okay? 1/5, which is about, or actually right on it, 20%. So 1/5, which is 20%. Okay. All right, let's take a look at the next one. Okay, this one is going to be like pretty much the opposite of that. This one does have overlapping events. You'll notice that right here. Okay, so there is an overlap. So we're going to use that full formula here. So this is when events have outcomes in common. Okay, the event can happen at the same time. So those are two different ways to kind of say the same thing. Okay, so we're going to use that full formula right there. So the overlap is basically going to be some number, okay? That's going to be how many are in common. So if you want to write that down, how many are in common? Okay, so you'll see in this example that we do right now. Now, here's the Venn diagram here. So you see probability of A and B. There's some that are going to share the same in both right here, okay? All right, so let's look at how it's shown in example. Spin a number higher than 4 or an even number in one spin of a spinner. Okay, so you'll probably, when it comes to these inclusive events overlapping, you're going to probably want to write this down. Okay, so it's a spinning number higher than 4. Okay, the spinner has the numbers 1 through 10. So I'm going to write those down. Higher than 4 starts with 5, 6, 7, 8, 9, and 10. Okay, and then or, so there again, there's that word or, that's always going to be for these inclusive and mutually exclusive events. And so a number that is even. So let's write that down next. So we've got the 2, the 4, the 6, the 8, and the 10. All right, so we're going to write those numbers down. Now, do you notice any of them in common? Okay, that's what we want to look at. So we have a 6. See how it ended up in both probabilities? We have an 8 and we have a 10. So there's 3. Okay, so in this case, the probability of A and B would be a 3 in this example. Okay, so now let's write out our formula. Remember, it's a probability of A. So what's the probability of spinning a number higher than 4? How many did we write down in that first category? 1, 2, 3, 4, 5, 6. So we wrote down 6. So 6 out of 10 was the first one. Then we're going to add the probability of spinning an even number. So 1, 2, 3, 4, 5. There's 5 of those. Now we do have an overlap, so now we want to subtract. What was that number? 3. So we're going to do 3 out of 10. This is a minus. Okay, so 6 plus 5 is 11. 11 minus 3 is 8. So 8 out of 10. So basically an 80% chance we have of spinning a number higher than 4 or an even number. Okay, so that's a pretty good chance. All right, so now these are all the types that we did. Okay, so remember these top 2 are more than one sample. That's a good way that I remember it. And then these bottom 2 are only one sample, and the key word is or here. Okay, so I don't know if you want to write that down because we circled it over here in the examples. So now let's just look at some random examples and see if we can figure out what it is and what formula to use. Okay, so it says state what type of situation it is and then find the probability. So first one, example A, we're rolling a standard number cube. Okay, so we're rolling a number cube. That's a 6-sided die basically. So first one, what is the probability of rolling a 1 and then rolling a 6? So how many outcomes is that? How many samplings is that? That's going to be more than 1. So we have 2. So we are going to multiply. Okay, that's the first formula. Okay, some probability of 1 and then rolling a 6. So there's only 1 out of 6, and then we're going to multiply it. And then the 6, there's only 1 of those. So we have a 1 in 36 chance of doing that. Okay, of rolling a 1 and then that. Just to see what that looks like percentage-wise, not a very good chance. It's about a 2.78% chance of doing that. Okay, so you can write it as this or as a percentage. Okay, number 2, what's the probability of rolling an odd number or so I'm going to circle that, or a number higher than 4. Okay, so here's the or, that means this is a 1 sample. Okay, so what am I going to do? I'm going to add. All right, by the way, back up here, this outcome did not affect that one, so this one was an independent event. Okay, this one was independent because the rolling the 2 different numbers did not affect the one before that. Number 2, so this one is rolling an odd number. So let's write down all the odd and see what we have. And if we have some stuff in common, then it involves an overlap, okay? So let's see, odds, and what kind of standard cube again. So there's not very many like the example earlier. So we've got 1, 3, 5, and that's it. 1, 3, and 5. And then the other one was rolling a number higher than 4 again. So that was like the example we did. So we have just 5 and 6. Okay, do you see any overlap? Do you see any in common? I do. This 5 and this 5. Okay, and that's it. So we do have one that is involved. So we're going to use that formula where we add. So what was the probability of rolling an odd number? 3 out of 6. Then we're going to add What's the probability of rolling a number higher than 4? That's 2 numbers out of the 6. We do have one in common, so we need to minus that overlap, okay? So by the way, this is an overlap, okay? This is a mutually inclusive, okay? But if we just say overlap, that means the same thing. And so there was one in that were in common, the 5s, and so 1 out of 6. So 3 plus 2 is 5, minus the 1 is 4, so 4 out of 6, so that's a 2 out of 3 chance, which is about a 2 out of 3 chance, which is about a 66.67% chance. So pretty good chance, okay? All right, let's try another one now. Rolling a fair 10-sided number die. Okay, so kind of similar like the one we did earlier. So it says, what's the probability of rolling a 4 or? Okay, so there's that word or. So that means this is 2 samples. Nope, sorry, just did the opposite. Or that means I'm just 1 sample. So that means I'm doing the addition formula, okay? And then we'll check to see if it has an overlap. So what's the probability of rolling a 4 or an 8, okay? So a 4, well, there's just one 4 on a 10-sided die. An 8 is completely different from a 4, so they have nothing in common. So this is a non-overlap, okay? Mutually exclusive. I think it's easier to say that, okay? So it's mutually exclusive. And so 1 out of 8, and then we're adding a 1 out of 10, which is, oops, not 1. We're not doing 1 times 1, we're adding 1 plus 1. So that's a 2 in 10 chance, which is 1/5, which is about 20% chance that we have of rolling a 4 or an 8. Okay, let's try the next one. What's the probability of rolling an odd or a prime? Oh, come on. Sorry. This won't stay there. Stay. Okay. So or, keyword or. So or was earlier also. So we're doing 1 sample. That means we're going to add. Okay. So what's the probability of rolling an odd or a prime number? Let's write these out again. Okay. Now this is a 10-sided die, so the numbers are a little bit more. So we've got 1, 3, 5, 7, 9. I think that's it. Did I skip any? All right, those are all the odds out of a 10-sided die, okay? Because this is right there, yep. And then a prime number, do y'all remember what prime numbers are, okay? 1 is not included. So 2 is a prime number because it's only divisible by itself in 1. 3 is prime. 4 is not. 5 is prime. 6 is not because it's divisible by 2 and 3. 7 is prime. 8 is not because it's got 4, 2, 3, 9 is not, and 10 is not. So there's our primes and there's our odds. Do we have any in common? Yes, we do. We have the 3, we have the 5, and we have the 7. So this is definitely an overlap. Okay, so we're going to add the 2 probabilities and then make sure we minus that overlap. Okay, so here we go. So we have the first one, rolling an odd. We've got 1, 2, 3, 4, 5 of those out of 10. Add the prime numbers now, 1, 2, 3, 4 of those out of the 10. Now we're going to minus the overlap. There was 3 on the overlap, okay? And then now we're going to just add and subtract. So 5 plus 4 is 9. 9 minus 3 is 6. So 6 out of 10 chance, which is what, a 3/5? 2 doesn't know 3. Yes, 3/5. So what percentage is that? That's about a 60% chance of rolling an odd or a prime number. All right, let's go on to now working with the standard deck of cards. Okay, remember there's 52 cards. You got to be a little familiar with the suits. Okay, so we've got, just a reminder, we've got hearts, we've got diamonds, we've got clubs. I'm not a good drawer. Okay, and then we've got spades. Okay, and these are black, and these are red. It didn't matter. Okay, all right. So what is the probability of picking a king, not replacing it? Okay, so not replacing it. So, and, so there's that word and. So this is the two samples, okay? Now, which one is it? Is it independent or dependent? Well, if you're not replacing it, then that's gonna have an effect on the second outcome is gonna have an effect, okay? Totally. So let me remind you, I'm gonna go back to here. Oopsie. It was this one right here. It was between these two, okay? So between these two, so see the second one is dependent, it does affect the other event, okay? So let's go back down to that. So how many kings are there? There are 4 kings out of the 52 cards. And so we're gonna multiply because that's the formula it calls for. Because remember, when we are doing 2 samples, if we have 2 or more samples, that means we are going to multiply. All right, and now I'm not replacing it, so I'm keeping it. So it's kind of like the one we did earlier. So it's like the dealer handed us a card and then is going to now hand us another card. And so that means there's only 3 kings left out of 51. So 4 times 3 is 12. And 52 times 51 is that big number again, 2,652. Is that divisible by 12? Yes. So I have a 1 in 221 chance of getting a king and then another king right after that, which that is kind of hard. So let's look at the actual percent. That's not even 1%. Okay. This is 0.45%, not even 0.5%. Okay. So you have a 0.45 chance. You have a 0.45 chance of getting a king and then another king. And that's why it's hard to win in poker. All right, what is the probability of drawing the jack of spades, keeping it, okay? And there's the word and. So again, this is 2 samples, okay? So that means I'm gonna multiply again. Keeping it and then drawing, this one's not replacing it. Yeah, that's the same thing, so be careful on that. I wanted to make sure we did this one right up here. So not replacing it is the same thing as keeping it. So we're kind of in the same situation again. So this is another dependent event. So remember, this one was dependent. This is another dependent. So what's the probability of drawing a jack of spades? Okay, so a jack of spades, there's only one of those. Okay, if you're not familiar with the deck of cards. A queen of diamonds, there's only one of those as well. Okay, so one of those out of the 52, you keep it. So that means I've got one less. The queen of hearts, there's still one of those out there, but I only have out of 51 cards this time. Okay, so this one was dependent because it affects, and we're not doing out of 52, we didn't replace it. So that would be 1 out of that big number again, 2,652. Which is even less than that. Jack of spades, keeping it, and then drawing the queen of diamonds. So we have a 0.04 chance percentage of getting that. 1 out of a 2,052 chance of doing that. Okay, so whenever you're dealing with a deck of cards, it's kind of difficult to, get a high percentage on those. Okay, what's the probability of drawing a king or a club? Oh, keyword or. Keyword or. So if it's or, that means I'm doing 1 sample, which means I'm doing adding or subtracting. Which one? Adding. Okay. How many kings are there? There's 4 kings out of 52 cards. We're going to add, how many clubs are there? There are 13 clubs. Now the question is there an overlap? Okay, well, let's think about that. There's 4 kings. You know why there's 4 kings? Because you have one of each suit. You have a heart, the diamond, and then the club, and then the spade. That's not a good drawer, okay? And so, and then how many clubs are there? Okay, well, the clubs are what those look like, and then there's a 2, a 3, a 4, a 5, 6, 7, 8, 9, 10, a jack, a queen, a king, and an ace. Okay, so there's all of those. Do you see any overlaps? Okay, because this is from the first group and this is from the second group. Yes, there's an overlap. The king of clubs and the king of clubs, right? Are we doing clubs? Yes, clubs. Okay, so there is one overlap, so we do have to subtract 1 out of the 52. Okay. All right, so there's 1 in common. So now let's add this up. 17. 17 minus 1 is 16 out of 52. So what's 16 divided by 52 percentage-wise? I always like to look at the percent. So this is about a 30.7% chance of picking a king or a club. Okay, so any of those clubs. So that's a lot. So that kind of helps out a little bit. All right, let's go to the last 3. What's the probability of drawing 2 hearts with replacement? So with replacement. Okay, so it does affect. So drawing 2 hearts with replacement. So if I draw a heart, how many hearts are there? There's 13 hearts out of 52. Okay, I'm going to replace it. Okay, so it does have an effect. By the way, this is 2 samples because I'm drawing 2 hearts. So there's not really an and there, but this is draw 2 hearts. So this is a 2 sample, so that means we're going to multiply. Okay, now it says with replacement, so I'm putting it back in there. So once I draw my heart, supposedly I'm going to put it back in the deck of cards. So there's still 13 out of the 52. So what's 13 times 13? 169 out of 52 times 52, 2704. Let's see if that divides into that. It does. So I have a 1 in 16 chance. So let's see what that looks like percentage-wise. That's about a 6.25% chance I have of drawing a heart and then another heart. Okay, let's look at number 9. What is the probability of drawing 2 hearts, keeping it, and then, so and then the word keeping it. Okay, going back to this one, was it independent or dependent? Okay, if I replaced it, okay, it didn't really have an effect on it, right? So this is an independent event. Forgot to mention that. All right, this one over here, I'm keeping it. So this one's going to be dependent. This one is going to have an effect because it's going to affect the total amount of cards that I'm using, okay? And so this is another 2 sample problem. So we are going to multiply, okay? So what's probably drawing of 2 of hearts? There's only 1 of those, so 1 out of 52. I'm keeping it. Now I want to try and draw the 3 of hearts. There's only 1 of those. Now I'm keeping the other one, so that leaves me with only 51 cards. Okay, and remember, I'm multiplying here. All right, so 1 times 1 is 1. There's that 52 times 51 again. We did this earlier. 2652. That was a really low percentage, which was 20. Let me make sure I get it right. 2652. 1 divided by 2652. So 0.04 chance of doing that. That's kind of tough. All right, and the last one, what's the probability of drawing a 2 of diamonds or any 10? Drawing a 2 of diamonds, or, there's the word or, so or means one sample. That means I'm going to be doing addition, the addition formula. So there's only 1 2 of diamonds. Oopsie. Out of 52 cards, there's only one of those. Okay, or any 10. Okay, so 10, how many 10s are there? There's 4 of them. Remember, the 10 of hearts, diamonds, clubs, and spades. Okay, so there are 4. Do any of them overlap? 1 2 of diamonds and that? Nope, they're completely different. So I have no overlap involved. So 4, 1, add those up. That equals 5 out of 52. What's 5 divided by 52? I have about a 9.6% chance of drawing a 2 of diamonds or any 10. All right, that's it.